So what I was attempting to do with these last two examples right here is to show you that we really don't have to worry about A and B being fractions, because when A is a fraction, it turns into a B, and when B is a fraction, it turns into an A. So the only two things that you really need to worry about are these two up here. A causes a stretch and B is going to cause a compression. That's pretty much the simplification of that. All right, so now we're going to look at C and D. C and D still do the same thing that they've done all school year. C shifts it left and right. D shifts it up and down. If we shift it left and right, we're going to change the vertical asymptote and the domain. If we shift it up and down, we're going to change the horizontal asymptote and the range. So if C is a positive 2, for example, we see that it shifted to the right 2. My equation's going to actually look like x minus 2. That's what I'll see in my equation. It'll say x minus 2 right there, because all I do is plug that 2 in the place. My vertical asymptote is now at x equals 2. That's where my domain cannot be. My domain cannot be at x equals 2. And then notice that here's the intersection of the two asymptotes, and that point is still over 1 up 1 from the intersection of the asymptotes, over 1 up 1. Might make it easier to turn that one off. You can see that I'm still go over 1 up 1. That means that I don't have an A or a B. A and B is what changes that 1-1 relationship to go right and up and left and down. But that's what shifting it to the right will do. Shifting it to the left, if we shift it to the left 3, we shift it 3 units to the left. My vertical asymptote is now at x equals -3, and my domain is now everywhere except -3. I will write some of this down in just a second. We'll see the examples and then we'll graph them. And D will, of course, shift it up and down. Remember, the starting value for C and D is 0, 0. If you change D, it's going to shift it up. That's going to change the horizontal asymptote and the range. If you put minus, it's going to change the horizontal asymptote and the range, and it's going to shift it down. So C and D should be getting extremely familiar as long as we don't change the A, find the intersection of the X and Y, the horizontal and the vertical asymptotes, and go over 1 up 1. That's the normal size. A and B will cause it to stretch or compress depending on which one. I'll do some algebraic examples in just a second. Okay. Okay, so these last two examples here show what the equations would look like. I've got g of x equals 1 over x minus 2. From the fact that the 2 is in the denominator with the x, we know that that's our c value. Remember, we changed the sign. We see -2, so we know that c is a positive 2. That means it's going to shift right. Because it shifted right, we know that our vertical asymptote and our domain has changed. The vertical asymptote is at the same place that the shift is, so it's x equals 2 because it's a vertical line and it's crossing the x-axis. And we know that the domain can't be 2. So find your vertical asymptote, and that's where the domain can't be. If you have to write an interval notation, you'll need to use a union. So numbers on the left side of 2, union with the numbers on the right side of 2. That includes everything except 2. The range would still be the same thing as it is up here. Negative infinity to 0, union with 0 to positive infinity, and the horizontal asymptote is still at y equals 0. Why is it all of that? Because we didn't shift it up or down. In this example, we've got 1 over x, and then the -3 is on the outside. It's not in the denominator. It's a number over here to the end of the problem. That's how we know it's a D. The D is always what we see. We see a -3, so D is -3. That means I've shifted down. My horizontal asymptote is going to shift down, which means that's where my horizontal asymptote is. It's at y equals -3, and that's where my range can't be. So why the range can't be -3. we're going to plug in, if we go from negative infinity up to -3 and then union that with 3 all the way to positive infinity, we'll get all the possible y values. There is no x value that we can plug in right here that would cause that graph to equal -3. So that is, I believe, an overall picture of what the problems could look like on your assignment.